taking a look at this review. So this first one here, the graph of the polynomial function is above, has a local extrema, max and min, and point of inflection at 0. So on what intervals is it increasing? So it's increasing here to here and here to here. So it's increasing from -5 to -2, and then again from 2 to 5. What intervals is it concave down? So where is it like a frown? So here, and then it changes to smile. So we would say that it is frowning from -5 to 0. So here's another graph. Points of inflection at -1 and +1. Where is it decreasing? So where is it going down? So it's going down, and then it's going down right here. So from -5 to -3, and then from 0 to 2. Where is it up? So where is it like a smile? So it's smiling right here, and then here's another smile. So it's concave up from -5 to -1, and then from 1 to 4. So this next one here, let's see. On what intervals is it increasing and concave down? So I'm going to highlight the concave down. And where is it increasing? Well, it's increasing right here. Where is it? Where it's going up. So I would say from -1 to 2. Where is it decreasing and concave up? So where is it concave up? Would be right here. And then where is it decreasing? Would be from right here. So from -infinity to -3. On what intervals is it decreasing at a decreasing rate? So I'm going to erase this. So where is it decreasing? And I'm going to highlight here and here. So where is it decreasing at a decreasing rate? So getting, that's got to be concave. So it's getting smaller. So it's concave down. It's getting smaller or more negative. And that would be on this part because it's getting steeper and steeper. It's concave down. So we would say 2 to infinity. And on what intervals is it increasing at an increasing rate? So right here in this blue, it's increasing. And where is it increasing faster? Well, that would be right here, because it at an increasing rate means it's concave up. So that would be from -3 to -1. So our second page looks at all of these here. So determine if it's true or false. The rate of change is increasing from 4 to 6. Well, is it increasing? The rate of change is increasing, yes, because that means it's concave up. The rate of change of k is negative from -4 to 0. Well, is that rate of change negative? Yes, because it's going down. K is increasing at a decreasing rate from 2 to 4. So 2 to 4. Well, I'm going to say that that's false because it's concave down. So it is decreasing, because it's not increasing there, it's decreasing. The rate of change of k is positive and decreasing. So from -6 to -4. The rate of change is positive, yes, at a decreasing rate. So is it slowing down? That would be true because it is concave down. All right, number 8. The graph of k is concave down from -4 to +4. I would say that's true. It's concave down, yep. The k is increasing from -6 to -4. Well, that's true. And from 4 to 6. Well, that's true as well. It's going up. Oh, I'm going to say it's not, sorry. I'm going to say that one is false from -8 because it changes right here. So that would have to be 2. I'm sorry about that. K is negative and increasing from 4 to 6. So 4 to 6, it is negative, yep, because it's underneath there. And is it increasing? Yes, that is, it's going up. These are kind of tongue twister ones here. K is decreasing at a decreasing rate from -3 to 0. And 2 to 4. Well, I'm going to say that's false because it's increasing right here. So how about this next one? K is positive and the graph is concave up from -3 to 0. Well, it's positive. It's above the x-axis. And yes, I would say that's concave up, so that's true. K is positive and the rate of change of K is positive from 4 to 6. I'm going to say that one's false because it's underneath the axis, so it's negative. All right, and our next one here. Let's see. So we have all 3 of these. Find the rate of change of f from 1 to 2. So f is our first one, so I need to see what's 2 times 1 cubed minus 1 plus 1. What's 2 times 2 cubed minus 2 plus 1. So if I take a look at this here, 2 minus 1 is 1 plus 1. So that's 0. No, that's 2. 2 minus 1 plus 1 is 2. 4, 8, no, 2 cubed, 8, 16. So that's 15. So again, we have f of 2 minus f of 1 over 2 minus 1. So that would be 15 minus 2 over 2 minus 1. So 13 over 1 is 13. The average rate of change of f from -2 to 0. So we have f of -2 minus f of 0 over -2 minus 0. So the bottom's -2. So what's f of -2? So 2 times -2 cubed minus -2 plus 1. So that's -16, -14, so that's -13. And f of 0, so 2 times 0 cubed minus 0 plus 1 is 1. So we have -13 minus 1. So we have -14 over -2 is 7. Find the rate of change of g of x. All right. From -1 to 4. So g of x, we've looked at this. There's 2 different spots here. So it says we use this top one when it's less than 3 and this bottom one when it's greater than 3. So g of -1, we'd plug it into the top one. So 4 minus 2 times -1 is 6. And then g of 4, since that's greater than 3, we'd use the bottom one. So 4 squared plus 2 is 18. So we could do g of 4 minus g of -1 over 4 minus 1. So if we do that, we have 18 minus 6 over 4 minus -1. That would be 5. So we have 12 over 5. So from 0 to 3, so again, I'm going to do g of 0 minus g of 3 over 0 minus 3. So the bottom we have -3. So where am I going to put 0? Well, 0 is less than 3, so in that top one. So 4 minus, so g of 0, 4 minus 2 times 0, so that's 4. And then g of 3. G of 3 we'll put in the bottom one, so 3 squared plus 2 is 11. So we have 4 minus 11 over -3, so -7 over -3, so that's 7 over 3. All right, so the next one, from -4 to 2. So g of -4 minus g of 2 over negative 4 minus 2. So we have negative 6 on the bottom. So g of negative 4. So negative 4 means we have to plug it into this one. So g of negative 4. And I already forgot what it is. So 4 minus 2x. So 4 minus 2 times negative 4. Well, that'll give us 12. And then g of 2. So where are we going to plug in g of 2? Well, also that top one. So 4 minus 2 times 2. So 4 minus 4 is 0. So we would have 12 minus 0. So that's going to give us negative 2. Find the average rate of change of k. So k is that table. So negative 2 to negative 1. All right. So k of 2, negative 2, minus k of negative 1, negative 2 minus 1. Oh, sorry, that's just a 1. So over negative 3 and k of negative 2, so we have 8 minus 4. So we have 4/3, negative 4/3. Find the average rate of change of p of x from negative 1 to 5. So p of negative 1 minus p of 5 over negative 1 minus 5. So on the bottom, negative 6. And what is p of negative 1? Is 1. P of 5 is 3. So 1 minus 3. So let's see, that's negative 2 over negative 6. So that's positive 1/3. And then again, we have p, and I could do it the other way, p of 1 minus p of negative 2. Or 1 minus negative 2, so we have a 3 on the bottom. Well, what is p of 1? Is negative 1. Minus p of negative 2. It's not here, it's way up here, so that's at 3. So we have negative 4 over 3. All right, determine if the following are concave up or concave down. So let's see. The nice thing, I noticed that these are all going up by 1s. This is going up by 1, 2, 3, 6. So the rate of change is increasing. So the average rate of change is increasing. So it's concave up. Now these, they're all going up by 2s. All right, so let's see. So this is going up by 4, 6, 4, and 4. So I'm going to say neither, because it's not increasing, or just average rate of change, not increasing or decreasing. So this one's going up by 3, which is nice. So now we can do that shortcut and just check this one. It's going up by 7, up by 5, up by 2, up by 1. So that is decreasing, so it's concave down, because the average rate of change is decreasing. All right, this next one, those are, the left is all going up by 1. So let's see, this is going up by 2, up by 3, up by 6, up by 5. So this is going to be a neither, because it's going up and then down. This one is going up by 1, so let's see, down by 32, down by 16, down by 8, down by 4. So this is going to be concave up, because even though they're all negative, they're increasing, so the average rate of change is increasing. And this last one, these are all going up by 10, so let's see, down by 2, down by 2, down by 4, down by 8. So this is going to be neither, because they are decreasing, and this one here is constant. All right, so find the least possible degree. So this is where we're finding those differences. And again, these are all going up by 1s here. So if we look at our difference, up 1, 4, 7, 9, 10. So that's a difference of 4, 3, 2, and 1. And now they're all changing by 1. So this is a third difference. So it's degree 3. These are all going up by 2's here, so that's good. So we can say down by 4, down by 2, 0, up by 2, up by 4, up by 2, up by 2. So those are the second difference. So this is degree 2, which would make it a quadratic. 30, these are all going up by 5. So let's see here, down by 5, down by 2, up by 1, up by 5, up by 11. So let's check the second difference, down by 3, up by 3, up by 4, up by 6. All right, let's look at this next one. Up by 6, up by 1, up by 2. Let's see, did I do this right? This seems a little crazy. Up by 5, up by 11, down by 3, up by 3, up by 4. So this one is up by 5 and up by 1. So would that be neither? Let's try this again. Let me erase and start. See what we can find here. So this is going down by 5, down by 2, up by 1, up by 5, up by 11. So our next difference, up by 3, up by 3, up by 4, up by 6, 0, 1, 2, 1, 1. Oh, so there it is. So this is degree 4. I must have done something wrong there. All right. But one thing I notice on these are not the same. So we actually have to find what is our average rate of change. So we can't just do that difference on this one because these are going up not at a constant rate. So if we find that average rate of change here, that y over x, we've got 1 over 1, 3 over 3, 5 over 5, 7 over 7, 9 over 9. And those are the same, so it's degree 1, and it's linear. All right. So these you could take a look at the graphing, and I'm going to have you graph those into Desmos, and you'd find that this one is neither, this one is even, and this one is odd. Or you could do it by plugging in numbers, because this one we know f of x is the same as f of negative x, and our odd one, f of negative x, is the same as the opposite of f of x. So if we look at a graph, this one is going to be odd, this one would be neither, and this one would be, it has, if you flip it in half, it's the same, so it's even, and it's odd because you can turn it or rotate it. All right, the polynomial function below is even, and a polynomial p is odd. So this one's even, and this one's odd. So we got to figure out what a would be. Well, I know if it's even, it has to be the same. So this would have to be 8. Because, again, if I was to flip this over, negative 3 and 8 is up here. So that means over here has to be 3 and 8. And if this one is odd, again, we said if something's odd, it rotates. So if this is 3, 4, over here is negative 3, negative 4. So if this is negative 3 and that's 3, this is negative 4, this has to be positive 4. Find the values of the A plus B. Oh, wait, that's what we did, sorry. Find K of 2 plus P of 2. Okay, well, K of 2. Well, if we know that that's negative 2 and it's even, K of 2 has to be 6. P of negative 2. Well, if it's odd, this would have to be negative 7. So our answer would be negative 1. Oh, sorry, this is negative 6, so that's negative 13. All right. K of negative 1 and P of 3. So K of negative 1. So if that's 1 and 4, this has to be 4. And P of 3. Well, if it's negative 3 is 2, positive 3 would be negative 2. So we have 4 and negative 2. So K of negative 1 equals 4. P of 3 equals negative 2. Find the average rate of change from negative 5 to 5 on P. So if it's 5, this would have to be negative 4 because it's odd. So we have negative 4 minus 4 over 5 minus negative 5. So we have negative 8 over 10 or negative 4 over 5.